Next up, a collection of learning sessions from our Power BI women community.
We all know good data modeling is essential to effective communication in Power BI. So next up, we have Kelly Broekstra, who is an information management, business intelligence, and project management specialist with extensive data warehouse development experience, and who has a passion for understanding clients' needs to create the best solution achievable. Kelly's going to speak to us in this session about how different data modeling decisions affect your reports.
Hi, thanks for that awesome intro. Yes, I'm Kelly. I'm based in Melbourne, Australia. I'm a mum, a spouse, a runner, a volunteer at a local youth group, and I spend most of my working time as a business intelligence solution specialist. Today, I want to talk to you about data models and how to effectively communicate with the right model within Power BI so that you get the best communication out of that model. Now, when I say effective communication, I mean answering the business's questions quickly and accurately, making a model that everyone can understand, not just you. So firstly, I want to clarify, I'm not talking about this type of model. I'm talking about this type of model, a Power BI model. Now, for those of us that have been working in Power BI for quite a while, we'd all be very familiar with the flat file model. So you've got a single table. It's a connection to an Excel or a connection to a source system, and all that's coming through is a single table. It's great. You don't need to create relationships. You don't need to worry about many-to-many or one-to-many cardinality. You don't need to worry about cross-filter directions. You have all the data there and away you go. Power BI compresses that data quite well, so the report performs. Everyone gets the data they need, and it's all wonderful. Unfortunately, more often than not, your boss or someone else from the business will come to you at some point and they'll want more. They always want more. They want you to add data from another spreadsheet or from another system. And after not too long, you'll have something that looks more like this. So where's the happy medium? The medium between the single flat table and the crazy star schema, which I hope nobody actually has in their environment. It's crazy. What we're actually aiming for is a star schema, and I hope most people have heard that term before. Now, before you go out and buy the book and read the whole thing, because it's very chunky, which, let's face it, no one really has time to do, let me give you a few basics. So a star schema looks like a star, like the one that we see here. The fact table is in the middle, and the fact table needs to represent a process or something in your business that has happened, okay? Not just the data that's coming through the system. It needs to actually model something that has happened or a process or a workflow within your organisation. It's actions. It's things that have occurred. And it includes with it numbers, things you can sum, aggregate, find the min and max of, do calculations on, that kind of thing. And the fact table also has within it links through to the dimensions. The dimensions are the points on your star. They're the nouns, they're the descriptions. They're what you filter things by, and they're what you tell your stories with. So they sit on the outside, and you can have as many of those as you need. Dimensions, most people kind of understand. Everyone puts their data in dimensions, and it all works. It's fact tables that I find people get more confused about. So just to clarify a few things and give you a few things to consider. Fact tables, you can have more than one fact table in a model. I quite often have conversations with people. In Power BI, they have one beautiful fact table that tries to do absolutely everything, and that's it. You can have multiple fact tables that complement each other. And each fact table should represent either a different process or a different action within the bigger process, or they can have different grains. So a good example would be a sales system, an invoice level grain, so where you have a line per invoice item, might have a customer ID, an invoice date, the number of things that were purchased, maybe something like that. That's one fact table. You might have a second fact table in your model that talks more to the products that were purchased on each of those invoices. So the grain for that would be the product line as opposed to the full invoice. So that's an example where you'd have two complementary fact tables that work really well together to describe an overall business process within your model. So you can always have more than one fact table within a star schema. Just make sure that you link your fact tables through dimensions. Don't try and create relationships from a fact table to a fact table. It tends to get a bit messier and not perform as well. But you can have multiple fact tables. The other thing that I do want to cover is there's actually 3 different types of fact tables. The one that we see most often, that we get from most systems nowadays, is a transactional fact table, where you have one line per transaction. So a sales item is a really good example, or a transaction might be a hire or a promotion in a HR system. It represents one line, and that line generally doesn't change. Comes through from the source system. Once it's in, it does not change. It's happened. We're not going to go back and change the order, change the number of items that were purchased. They've been purchased. They're done. So that's the transactional fact table. That's what we see most often. The second type of fact table, which does actually still have a big use, is an accumulating snapshot table. So this is where you're modelling a process or a workflow, and that particular item does certain things on certain days. So you can have different dates stored within your fact table to represent different days, and I'll show you an example shortly. The third example is a periodic snapshot, and that looks more at snapshotting what's happened at a specific point in time, where that point in time is a regular occurrence. So a good example is a bank statement. So the periodic snapshot would have a line for customer 12345, a statement date, maybe the 1st of January, and an opening balance and a closing balance. It then have a second line for customer 12345, the 1st of February for the statement date, and it'd have an opening balance and a closing balance. It gives you that ability to see the opening balance and closing balance really quickly without having to sum up the whole history of the transactions that could have happened in that system. But don't sum it together. Don't add all your closing balances for the year. You'll be rich, but it's not actually a true indication of what's happening. Now, I found a really nice image that sort of describes these from a book. That book's just down there. I've never really found the image online. So I took a photo. That's why it's not the greatest quality. But it's a good visual representation of the 3 types of fact tables: the discrete or transactional fact table, where things are single items; the evolving fact table, where something might move along, a process, an order, shipment, delivery, payment type process might have happened, and then a reoccurring fact table where everything works on a very regular, reoccurring type basis. I don't have much time left. We're not here all day, so I'm not going to show you how to create the model with the star schema. I'm not going to show you how to change your existing model into a star schema, and I'm not going to talk much to how a lot of this is done in Power Query and or in your ETL process, and how you need to manipulate your data. What I do want to do, though, is talk through a couple more examples. So I've spoken a little bit to the sales system, which a lot of people have, so it tends to come up quite often in conversations. So a customer buys a product in store, and the store wants to know the most popular products, how much money they've made, what the markup was, which customers buy the most products, the time of day that's the busiest, those kinds of questions. So in that scenario, they're one-off events. They're events that happen and then nothing else happens afterwards. The customer very rarely goes in and returns the product, but that would be a different process. So you want a transactional fact table where you have one line for everything that's happened, whether that's a product line item or an invoice item, depends on your business's requirements. You then have dimensions of that around your customer, your store, your product. you'd have a date dimension, and you'd possibly even have a time dimension, which would be separate to your date dimension. And that would just list all the different times of the day. And that helps with analysis around what times of the day are busier. And you can combine that with the date and work out, you sell more on a Friday afternoon, for example. Put more staff on at that time. Make sure you've processed all of the shipments in so everything's on the shelf ready to go. Those kinds of things is the analysis that you can do with a transactional fact table with a separate date and time dimension. Another scenario, a HR system, for example, a person is hired, they're promoted, they leave your organisation. The manager wants to know things like turnover rate, different demographics around the people that work within the organisation, how long someone takes generally before they get promoted, what are their reasons for leaving, those kinds of things. So once again, you could do this as an evolving, as an accumulating snapshot fact table where a person is hired, they're promoted, they leave. But an accumulating snapshot doesn't give you a lot of room for they get promoted multiple times. Unless you've got a finite number of times someone can get promoted. The accumulating snapshot model doesn't work quite as well. But what does work, though, is the transactional fact table. It's just a little bit more difficult to do the calculations around how long has someone stayed in a position before they got promoted or before they left. So think about the kind of questions that your business is asking and build the facts tables around what you need to answer. And this is a really good example of where you might have different types of fact tables. You might have a transactional fact table, one for hires, one for promotions, one for terminations, and then you might actually have an accumulating snapshot table that sort of just describes a summary of the history of that particular employee. The third scenario or example I sort of want to speak to is one I get quite frequently, which is an inventory or a stock analysis or anything to do with the workflow, basically, but I'll use the stock example in this as we discuss this. So a stock item is ordered, it's received at the warehouse, it enters the warehouse, it's then purchased by a customer online, it's packaged, and then it's shipped out. So you can do that as and I'll show you some pictures. You can do that as an accumulating snapshot like this. So where you have the stock item and you have the dates sort of across the top and you list out all the different dates, and then you can do a calculation of the number of days in each phase. Or you can have a transactional fact table, which is more of for this particular stock item, it hit the warehouse, it was ordered, it was received, it hit the warehouse, and these are the dates. So this is good to sort of, you don't need to go and update things. This just lists things out. But it does make it a little bit harder to do reporting. I can report on a single item and see what it does. But if I want to know how many items are currently in my warehouse, I need to search for everything that has a warehouse date of before today or whatever date I'm looking at this report for. But then I've also got to join to things that haven't been purchased. So the DAX that I'd need here would be a lot more complicated. Whereas in my accumulating snapshot, it's quite easy to just filter and say, all I need to do is drop on count of my stock items and filter by where the warehouse date has already happened, but the purchase date hasn't. And that gives me the number of items I currently have in stock. I can still see which items have been in stock for the longest and can see all the dates associated with them. And I can drag and drop a lot more stuff. So the difference between the two models, this one is very much I can just, drag things on. I can produce my reports and answer questions very quickly. The transactional fact table, I need to write DAX, and some of the DAX can get quite complicated because I'm trying to join on other items within the table that do relate but also don't relate. So there's a lot of remove filters and complexity in those DAX calculations. So I just wanted to sort of sum up. Thinking about what you're trying to model will really help you with what you're trying to build. So think about the business requirements. What are you trying to solve and what questions are you actually being asked? And model real life business. Don't just model the source data that you got and go, that's the only way I can do it. You really want to make sure that you're modeling your real life scenarios so that you can answer the real life questions. Now, some of this advice should make your reports faster, smaller, and more scalable. Sometimes not the case, but that's kind of the idea. But more importantly, they make it a lot easier for you and for anyone else at your business to interpret the model, play with it, add their own visuals, add things to the visuals. You don't need to know complex stacks to get all that working. So that's what we're trying to achieve. I hope you've learned something today from this session about how to model your data a little bit better. Stick around for the next sessions. They look really interesting, and I can't wait. And thanks for listening.
Thank you, Kelly, for sharing your insights into effective Power BI modeling techniques.